and because of a lot of things, so I've just decided to do a video on Stata. So I'm just going to show you how you can get started with Stata and prepare for your exam, right? So what you're going to do is you're going to start my Stata 13, right? I know there's Stata 16, there could be Stata 18, I'm not sure, but this is Stata 18. It can I hope you pass the exam, and so let's start. What we're gonna do here is I'm just gonna get a simple data set, right? So I'm gonna do file, then I'm going to example data sets, then example data sets installed. So here that I'm gonna work with is I would like this one because it's simple, so it's saying the data is ready. So what I can do is I can minimize the screen. As you can see, I've actually clicked twice, so I now I've got two data sets. I'm going to remove one, sorry guys. So I'm just going to say delete because I want to have one, right? So you can see there's only one data set, right, which is also here, right? So with this data set, what I'm going to do, I want to view it, so I'm going to click here, data editor, right? You can now see this is the data set that I have imported. It is got age, race, married, never married, grade. So this data set is basically about women in America, and they collected the data, and they were mainly interested in the wage that the person got, and the hours, and then the tenure, which was specifically the wage, and the tenure is how long you've been working for that company. So it's very interesting. We want to do a regression to see the relationship between the wage and the tenure. That's what we're going to do in this very short time that I'm going to be with you guys. Okay, so let's do the interesting stuff. We want to regress the wage and the tenure. So what am I going to do? Okay, here's what I'm going to do. I'm going to go back to my main menu. I'm going to say graphics, two-way graph. So what I'm going to do with this two-way graph, I'm going to see the relationship between the two. So I'm saying create, right, basic plot, yes. So my y variable, right, this is the one that I want to be on the vertical axis. I'm going to put wage on the vertical axis. Then I'm going to pick my x-axis as the tenure, all right. Then I'm going to accept, then okay. So we can see that we have a two-way plot. There it is, right? We can see that from this plot the minimum number of years was there, and the maximum was probably 25. Then the number of hours worked, they also increased along the axis, but we can see that there is a relationship there. So what you're going to do is you're going to fit a model, right, so that we can actually fit a linear line there to say, so that we can have a model for this relationship. Okay, so what I'm gonna do now is I'm gonna go say okay, statistics. Then from statistics I'm gonna say okay, look at the post estimation, right? So when I look at the post estimation, what I'm gonna do is I'm gonna look at the prediction and residuals that you performed. Okay, so what I'm gonna do here right now is I've got my two-way wage and tenure, right? Okay, so we want to fit a linear regression, right? So what we can do is statistics, summary tests, right? Descriptive statistics. Then what we want to do here is a linear model, right? Let's do the linear model. It's just going to be a simple regression. So my dependent variable, right, is going to be the years, the wage, right? Then my independent variable is going to be the tenure, right? Then I'm going to fitted my model. This is what you call fitting a model, right? So I'm going to look at the model. These are the model results, right? So we can see that here it's written regress, wage and tenure, right? So we can see the number of observation were 2000, right? The F statistics 72, the F probability is 0, the R squared is 0.033, the adjusted R squared is 0.03, then the root mean squared is 5.3. But what we're interested on here is really the constant, right? Like if you look at the constant rate, we can see it was 6.6. Then all these are the statistics. But what we really want to know is the tenure and how it relates to the wedge, right? So we can see we can say that now the wedge. If we look at the tenure, you can see that the coefficient is 0.18. Then the standard error is 0.02. So if we divide this coefficient divided by the standard error, we get 8.92, which is the t statistics, right? Then we can see that the probability value of the t test is 0.008. So which means that to not accept the hypothesis, right? Then 95% confidence and the interval. So these are the summary statistics. Then if you look here, it's the sum of squared error. Then this one is the ms squared error, right? So with this model, we have just basically created our model, and we now know that what this means on a high level, right, is it means that each and every year, for every tenure, 1 year tenure, is associated with an increase, right, or the betterment of a person's life, an increase of about $0.18, right, each and every year, about 18 dollars, right, each and every year, that a person's income improves, right? That's what the regression is saying, right? So that's okay now for guys, that's okay for now. I think you now understand. So maybe what we can do finally is to then just do a two-way graph, and then say we're going to create another one, and it's still the same graph, but on our y we are going to change. I'm going to pick the it's not the wedge. I'm going to put the I have to create another variable, right? Right. Okay, so what we can do, what I want to do right now is I want to sort of estimate, right? I want to estimate so we are going to look at our post estimation model, then prediction and residual. We are going to create a new variable called predict, right? Predicted, right? So what this model is, you want it to predict new variables, right? So we're just gonna say okay. So it's showing that it is predicted 15. It is predicted, and there's 15 missing values generated, right? Okay. So with this predicted, what I'm gonna do, I can actually go to my editor, and you're going to see I've got a new variable called predicted. This is the one that I've created, right? So with this predicted, what I'm going to do, I'm going to view the relationship, right? So for me to see the relationship, what I have to do now is this is the time to do that step, right? So we're going to say two-way graph. Then I'm going to create a new one. Then I'm going to say my y variable is this new variable that I called predict, and my x variable is going to be, I'm going to stick to the same, it's going to be the tenure. So what you could do is, you may have like many, like if you want to do it, okay, so we just stick to this for now, I think. So I'm going to sort, right, then accept, then okay. So that's my fitted model, guys. As you can see, we have done basically everything. So if you are a student and you have got, it means that you have done your model. That's the linear model, and you can see the increase that's happening with each and every year, that there is an increase with the number of years that's associated with between the hourly wage and that. So what you can do if you're a student, what you may need to do is to highlight all this code, right? You can see I'm pressing my control key, then I'm highlighting this, then I'm going to right click, then I'm going to say send to do file editor, right? So I've sent this to do file, so I can now then say save this. This is the sort of submission that you may want to give to your teacher, right? So if you say /2, then you can say question maybe 1. Let's say your teacher had said that linear regression, right? Linear regression, and save it. So file, save as, just save it whatever you want, you can save it. I'm saving it here as YouTube. All right, and that's it, guys. So I hope you have understood. I'm gonna do more videos, but this was just an introduction for you to just get somewhere to start from, right? So thank you, guys. Bye.